In our sixth problem, we need to show that the locus of midpoints of all the normal chords of the rectangular hyperbola x square minus y square is equal to a square is given by y square minus x square whole cube is equal to 4a square x square y square. Now what do you mean by a normal chord? A normal chord is a chord of a curve that is both acting as a normal to that curve as well as it is a chord for the curve. Now if h comma k is the midpoint of this chord, then as we did in the chapter of circles, if h comma k is the midpoint of the chord for the circle x square plus y square is equal to a square, let's say this example, then the equation of chord whose midpoint is given to be equal to h comma k is given by t is equal to s1, that is t is given by x into h, replacing one of the x by h, plus y into k, replacing one of the y by k, is equal to s1. This s1 represents putting h in terms of x and k in terms of y is equal to h square plus k square. This is a shortcut for the formula of the chord whose midpoint is given to be equal to h comma k. We took the example of a circle. Similarly, we can prove for an ellipse or a hyperbola. This is an important formula which you should remember. So doing the same thing for the hyperbola in our case, if h comma k is the midpoint for the chord of our hyperbola, using t is equal to s1, the equation of the chord becomes, replacing one of the x by the midpoint h minus replacing one of the y by the midpoint k is equal to s1, and our s1 represents replacing x by the midpoint h and replacing y by the midpoint k. This is a shortcut which you should remember. Hence this becomes xh minus yk is equal to h square minus k square. This is an equation for a chord whose midpoint is given. Also, this chord is acting as a normal for the hyperbola. So we can write the equation of normal to be equal to x cos theta plus y cot theta is equal to 2a. Since this is a rectangular hyperbola for which the value of a is equal to b, this is the second equation and this is the first equation, and coincidentally these two equations are the equation of the same line which is acting as a chord as well as a normal for the hyperbola. So on comparing both the equations, we get h upon cos theta is equal to minus k upon cot theta is equal to h square minus k square by 2a. We get sec theta is equal to h square minus k square upon 2ah, and we get tan theta is equal to minus of h square minus k square by 2ak. And now we can very easily use sec square theta minus tan square theta is equal to 1, that is h square minus k square whole square upon 4a square into 1 upon h square minus 1 upon k square is equal to 1. On taking LCM, this becomes k square minus h square, and this is minus of k square minus h square. So this becomes h square minus k square upon 4a square into k square minus h square upon k square h square is equal to 1, or rather on taking the square, this was h square minus k square whole square, and this is also h square minus k square whole square. So this becomes k square minus h square whole square, or rather whole cube, is equal to 4a square k square h square. Now replacing k by y and h by x, we get y square minus x square whole cube is equal to 4a square x square y square. And this is the desired locus of the midpoint of the normal chord for the rectangular hyperbola x square minus y square is equal to a square. Hence our final answer is y square minus x square whole cube is equal to 4a square x square y square.